You already know that the derivative of sine x is cosine x, and the derivative of cosine is negative sine. We're going to use these and the quotient rule to find the derivatives of the other four trig functions. Now, I've given you the formulas here, but we're going to prove them. Tangent is actually sine over cosine. So if we want to find the derivative of sine over cosine, we'll use the quotient rule. So the derivative is low, which is cosine x, d high, derivative of sine is cosine, minus high, which is sine x, d low, the derivative of cosine is negative sine x, over low squared, which would be cosine x squared. Now, if we rewrite the numerator, we'll see that it's cosine squared x. Negative times a negative makes that plus sine squared x over cosine squared x. But the Pythagorean identity tells us that cosine squared x plus sine squared x equals 1. And 1 over cosine is the same thing as secant. So 1 over cosine squared is equal to secant squared x. So the derivative of tangent is secant squared x. Similarly, we can rewrite secant as 1 over cosine and use the quotient rule to find the derivative. So for this one, I have low is cosine, d high, the derivative of 1 is 0, minus high, which is 1, times d low, derivative of cosine is negative sine x, over low squared. So, of course, this first term goes to 0, and we get negative times a negative makes this positive sine x over cosine squared x, which I can rewrite that as 1 over cosine x times sine x over cosine x, which would be secant x times tangent x, which is the formula that we get for the derivative of secant x. Similarly, you could find the derivatives of cotangent and cosecant. It's the same process. Let's use these in more complicated functions. So if I want to find the derivative of x times secant x, well, this is going to be a product rule where my first function is x, my second function is secant x. So my derivative is the derivative of the first times the second plus the first function times the derivative of the second function, and we now know that the derivative of secant is secant x tangent x. So my final answer is actually just secant x plus x times secant x tangent x. There are no like terms to combine, so that is my final simplified answer. Okay, now let's try another problem. 1 minus cosine x over sine x. Now, I could use the quotient rule on this. However, when I look in the denominator, I see a single term. In this instance, I see two terms in the numerator, which means I can split this into separate fractions. And this would be 1 over sine x minus cosine x over sine x. And the trig identities allow me to rewrite this as cosecant x minus cotangent x. And by doing that, I won't have to use the quotient rule at all. So given the formulas I gave you, or if you derived them yourself, we see that this is just equal to negative cosecant x cotangent x minus the derivative of cotangent is negative cosecant squared x, and this turns into negative cosecant x times cotangent x plus cosecant squared x. Okay, now this particular problem, I need to use the quotient rule on it. I do have a single term in the denominator, so that tells me it's probably going to simplify at the end, but I don't know for sure. However, there's nothing I can do to simplify before I get started. So, using the quotient rule, I get low d high, the derivative of secant x is secant x tangent x, minus high, d low would be 1 over low squared. So if I clean up my numerator, I see that there are no like terms to combine. There's no x to factor out to cancel anything. I could factor out a secant x, but it wouldn't simplify anything, so this is my final answer.